Yeah, so Cameron Townshend from Sonatype. So I'm a solution architect based in Sydney, and I look after Asia Pacific. And what we do at Sonatype is we help you protect against the risk associated with open source libraries that you might use in your organization. And why is that a problem? One of the big things that we've noticed over the last few years is many of the high-profile exploits that have occurred have actually occurred through the use of open source libraries. So has anyone here heard of Equifax, the exploit that happened last year? So that Equifax exploit was done through a library called Struts2. And I'm actually going to demonstrate some of the aspects of that hack today, how it was actually done, how the hackers found the target website, and how you can actually find frameworks on the internet. So most organizations today use a lot of open source. Anyone here use open source? Anyone here ever used Google? Okay, a lot of open source in Google. Anyone ever used an Android mobile phone? Open source. We're all using open source all the time, and our organizations have to use open source to write software more quickly, because it's impossible to write all the software that we need to write in a modern business by hand from scratch. You need to use open source libraries. It brings a lot of power and a lot of innovation, but it also brings in a lot of vulnerabilities. So the idea is that you need to be on top of your use of open source. And I was at a bank yesterday actually where the devs were saying, we're not using open source. Well, the dev lead was. The two developers were sort of looking at him saying, are you sure? And then he says, not a problem for us. And then the security team was saying, I can't sleep at night. So the traditional sort of arguments you have between the developers and the security team happen all the time here in Singapore and other parts of the world. What also makes this really important is in Singapore, the Monetary Authority of Singapore has stated that financial services institutions need to produce a bill of materials, a listing of the components they use in their applications that they develop. And this is because they don't want to be part of these attacks that are using open source frameworks to be exploited. And what I'm going to do is I'm going to show you how, as a hacker, we can find an open source framework on the internet, and then how you can actually protect against the exploit using some tools that I can show you. So let me just explain what this problem is. This is a slide of the growth of open source. And I was at a bank, insurance company, sorry, in Sydney, and the CISO said to me, Cameron, I've had this application for 14 years. Why do I need to worry about open source now? What's changed? Why do I need to spend money on this problem? And this slide sort of talks to that. And what I was able to explain to her was that your developers used to write software from scratch. But today, modern software is built using components. Now, we at Sonatype run the largest Java component store in the world. It's called Maven Central. And last year, we served 52 billion libraries to Java developers globally. There's 9 million active developers working on Maven projects. It's a massive amount of data has actually been put into there, and a lot of libraries are being used all the time. 120,000 is the number of customers that we've got at Sonatype. We're by far the largest supplier of repository. A repository is a way of storing components in your network, and that allows your DevOps and your DevSecOps teams to be more efficient, to build software more quickly, because traditionally programmers will download libraries off the internet very, very slow, and it's also risky. For example, a couple of years ago, a developer wrote a very popular library in the JavaScript world, in the NPM world, and he pulled it because he had a fight with the NPM organization. When he pulled his library, he actually broke builds at Facebook. He broke builds all around the world. So the idea is, how do we protect ourselves against these sorts of events? Just this week, as a matter of fact, a JavaScript library was hijacked, and a malicious attacker put a crypto miner into the JavaScript library. I don't know if anyone heard about that. Was that actually news here? Yeah, you heard about that. So basically, anyone who was using that JavaScript library, if they downloaded it, for a 2-day period, they're actually downloading a JavaScript library which had a crypto miner inside of it. And so all of their customers that were using that were actually mining cryptocurrency for the attacker. So this is going to become a bigger and bigger problem as open source use becomes exponential. And the next slide actually shows you the growth of open source. The purple one there is Maven, which we run, Java. And then the red one there is NPM, which is JavaScript. And what you can see there is NPM was almost nothing 2 years ago, and now it's actually 59 billion components were downloaded last year, NPM libraries. No wonder security people don't know that this has hit them, because only developers have started using this over the last 2 years. So how, as a security professional, are you going to know that this is actually going on, unless you're actually tracking every single library, every framework yourself? Now, are all these components good? No, they're not. They have a lot of vulnerabilities inside of them, but traditionally, when a vulnerability is found, the people that write these libraries are told about it by the researcher who finds it, and they'll issue a patch at the same time they issue a CVE. The CVE is basically a report of the vulnerability, and the problem with that process is, okay, it's great, they release it, but now they've published the exploit. So an attacker can take advantage of organizations that are very big, like banks, are very slow to upgrade their libraries that they've got. Very hard for them to patch all their applications very quickly. So the attacker has a first mover advantage over the defenders. So the idea is that if you are using these open source libraries, which you are, stay on top of it using automated tools. There's 59 billion of them downloaded last year across hundreds and hundreds of thousands of libraries. If you were to do that manually, you could not stay on top of it. So the whole idea is you want to automate that across your entire software development lifecycle. And I'll show you how to do that in a minute. The other thing too that's changed is that 80 to 90% of modern applications are assembled. So what that means is in the old days, developers would open up Emacs and start writing a program from scratch. Doesn't happen today. All modern applications are built using open source libraries and third-party libraries because they're being pushed by the business to write software very quickly. You have to do innovation. You have to always be delivering new features and software, and we don't have the resources to write it all from scratch. So we use these components. Java, JavaScript, NPM, Bower, .NET, Docker. All of these things are open source, and they're all being used to write software. But we don't actually have control over it. And that's the change in the DevSecOps world. When you're a security expert, you actually don't realize that the developers are doing this to you. Or you might, but most developers don't tell people what they're doing. They have a lot of control. They bring these libraries in. They use them. They don't know if they're secure or not secure. But you as a security professional, you actually own the risk, but you're not aware of it. So one of the things you want to do is actually be able to show this and then bring the security to the surface so you can see it. And I'll show you how to do that. We actually did a survey. We found that 1 in 5 organizations were either breached or suspect of being breached through an open source component in the last 12 months. And here's the classic example. So Equifax, I'm sure we've all heard of Equifax now, and we do beat up on them a little bit. And I feel sorry for them because it's actually very difficult for them to stay on top of it. The big organisation, thousands of applications. They're not the only organisation that was hit through this particular vulnerability. There's actually a lot of organisations were hit. So March the 7th, security researcher had worked with the Struts team. They had found a vulnerability. It was actually done by hand, the research. They issued the CVE and they issued the patch on the same day. Responsible reporting. Now what happens? March the 9th, 2 days later, an attacker ran a Who Am I on an Equifax server. That tells you you've got 2 days there potentially or less to actually patch your service before people are going to start probing your network. Unfortunately, the Equifax team had made a number of mistakes because the Who Am I came back with root. So the attackers now know, oh, okay, I can actually own this box because this exploit is a severity 10 CVE. It allows for remote code execution. Extremely serious problem. Now what happens? July the 29th, Equifax realized they'd been breached. It was literally 6 months. And the way they realized they'd been breached was their network team noticed unusual activity on the network. There was too much outbound traffic. So yes, the network and the SIEM and the firewall people, they did find this, but there's 6 months of infiltration there that they missed. The actual data exploit was actually coming out between May and August, 145 million records. In America, the data that was stolen was name, address, date of birth, social security number. You can't change that data. You can change your password, but you can't change your date of birth. The risk to Equifax is that all of these people have had identity theft. So now there's legal action. The CEO, the CIO, and the CISO at Equifax all lost their jobs over this, all over one vulnerable library that they didn't patch. There was a probe done for a number of months there. Now they're in crisis management. They were called up in front of the US government. They're being sued. Major disaster. All over something that was actually quite preventable if they were actually on top of their patching of libraries. Actually, there was another CVE published. So what I'm going to do now, I'm actually going to show you how to use Google to find struts on the internet. Because struts pages generate a file with a signature. Let's show you that. I'm going to use Google here. Now when I'm looking for struts, I know that struts generates pages with a signature that looks like this. Hopefully you can see that. Okay. 294 million pages there. All of these pages are written in struts. So I'm an attacker. I'm an attacker. I now know how that website was written. And I'm guessing that if they're using struts on March the 9th, 2 days after a security alert was issued, they could still be vulnerable to the exploit. They might not have patched. That's American Airlines, the first site there. Many, many organizations in the world use struts, very, very popular framework. The framework is used to generate web pages, like WordPress or PHP. So now I'm an attacker. What do I do next? Well, I might filter this for the Fortune 500 companies. Or I might just filter it for Equifax. Could be a targeted attack. Oh, okay. So what I've got here is I've now got 100 pages at Equifax, written in struts. They're still up there, by the way. They may or may not have patched their server since the attack was announced. But I'm an attacker. I can now target this website. It's a very, very popular technique for hackers to actually go and find web pages using their signatures. There was another very famous attack a couple of years ago called the Panama Papers. The Panama Papers was data that was stolen about tax avoidance. And funnily enough, the Prime Minister of my country, Australia, he's the Prime Minister, and he's actually using this offshore account to hide his income. The Queen of England was also caught up in this. Many, many senior politicians were caught. Now, what was the framework? The framework that was used in that attack was Drupal. Drupal is a content management system for creating web pages. It was not patched. And now the attacker has used a signature very similar to this. And as a matter of fact, the data that I've actually shown there, I actually worked this one out. I was quite happy with that. There's actually a document here, quite popular, Google hacking for penetration testers. It's pretty much one of the standard documents. The guy who wrote this is a pretty clever guy called Johnny Long. He gives you a whole bunch of examples here. And he shows you, most of his examples are about hacking WordPress and PHP sites, but the technique's the same. You actually go and find the admin module and you break in. Recommend that to you if you're ever interested in how this is actually done. But let's just sort of back up a step. What I'm saying is that if you're using a framework and you're generating web pages, these web pages have a signature. And these frameworks can now be exploited because when a CVE is published, the exploit is often published with it. So the attackers are taking advantage of this particular attack vector to go and exploit these frameworks. And think about the return on investment for an attacker. Rather than sitting there and doing very, very deep, detailed work on your site, trying to work out what sort of exploits you can try, all he needs to do is attack a framework using a bot. And as a matter of fact, there's a database of these that you can subscribe to called Shodan. Anyone heard of Shodan? So Shodan is actually a database of these results that I'm showing you. It lists out websites, IoT devices, power plants, nuclear reactors if you want to go that far. They're all in the database. So the idea is that you're attacking the frameworks that are used by these organizations to break in. Very, very lucrative way, very high return on your investment as an attacker to attack these frameworks. So that's the doom and gloom. Let's see how we fix this. Go through that. Struts are still being downloaded. We actually serve struts, so we're part of the problem, I guess. But we found last year that 3,054 organizations downloaded the exact vulnerable version even after the exploit was published. So what we do, I'm just going to get rid of that, sorry. So what we do is we actually have decided to solve this problem. We actually built Maven Central and we serve these libraries. And a number of years ago, a bank came to us, a large US bank, and said, we've downloaded all these libraries. We found they were vulnerable during a pen test. Can you help protect us in future? And we said, yes, we'll do that. We actually built this product for them that will scan these libraries that you're using and match them to known vulnerable libraries and tell you about it early in the development lifecycle. And this is the DevOps tool chain that a lot of organizations are moving to, where developer downloads from source control. He downloads libraries from his repo, Nexus repository, which downloads libraries from the public internet. This is actually one of the first control points. A lot of organizations don't do this. The developers can just go out and get whatever they want. And that's a risk, because we've got hundreds or thousands of developers, and they're all bringing in libraries. How do you know what they've brought in? How do you control that, or even know what they've done? So by putting in this pattern here, this architecture, at least all the libraries are going through the repository, so you can actually track what they're using. When they do a check-in, that will issue a build, which will bring in the same libraries from the repository manager. That will then push in their builds into the repo. Then they deploy from there into their different environments. So this is what we call a DevOps toolchain or DevSecOps toolchain. It's continuous integration and continuous delivery. This architecture is very, very powerful. Quite simple, but very powerful. Because some of the things that we're actually showing you here are very, very good controls that are quite easy to implement. Firstly, developers are no longer allowed to go to the internet to get libraries. So what typically happens in most banks that we work with that do this is they actually put a proxy rule in that developers can no longer go out and grab libraries directly. They have to access them through the repository. And the advantage is that the security team can now make an assessment on what we actually have in our organization. Let me show you that. Okay. So here's the repository manager. And this is the list of all the libraries that we've downloaded. I've got Maven, I've got NPM, and I've also got PyPy in this particular example. But for each of these different frameworks and Docker and all the other languages, I've got a health check. So I can see, for example, in my Maven repository that I've got 46 critical issues, 35 severe issues in my Maven. I've got 15 critical ones in my NPM. And I've even got them in my PyPy, in my Python. So I can actually click on that and log in. But I've now got visibility. That's the first step. So when you're having a conversation with the developers, you can actually say, okay, what are we actually using? All right, and is it vulnerable to exploit? And do I have security and licensing issues in my repository? Very, very quick and easy to do that. The whole idea is that once you have visibility of it, you can start addressing it. You don't want to get the phone call from the CEO in the morning saying, I just heard about my buddy at Equifax, he just lost his job. Are we going to be the next Equifax? The whole idea is you don't want to be the next Equifax. You want to stay on top of your use of open source. You're using it, It's only going to get bigger. The problem's going to get bigger and bigger in the future. So manage it, control it, and use a tool like this to automate the control of it to actually know what you've got. I'll show you a bit more about that in a minute. So let's just recap. Third-party libraries as a source of risk. So we ran a survey in 2014. We found that 14% of organisations thought that it was a problem. Last year when we did the same survey, 20% of organisations thought there'd been a problem. So this is saying you suspect or have verified that a breach relating to open source components has occurred to you in the last 12 months, up to 20%. This number here is really interesting. This is actually from Gartner. This is not from us. This is Gartner's report. So Gartner wrote a report on the use of open source, and they said 50% will have suffered damage by failing to manage trust in their software development lifecycle, causing revenue loss of more than 15%. If you look at Equifax again, not only did those 3 executives lose their jobs, the share price went down 20%. And it's fighting back. But they've got all these legal problems too now because they're going to be sued by people who lost their data. Now, if you're doing PCI work and credit card processing, if you have a breach like this, you could easily lose your PCI compliance. That's an existential risk for a bank. You don't want to have that conversation. So you have to make sure you're managing this problem. And a lot of what I've talked about is Java, but we also do JavaScript. And one of the problems with JavaScript is that there's lots of vulnerabilities in JavaScript. But what makes it even worse is that the vast majority of JavaScript libraries are maintained by one person. In fact, Struts Java library, 80% of the code is maintained by one person. These open source libraries have very few people actually working on them, despite what you might think. And a JavaScript library that's maintained by one person could easily have a vulnerability in it, and because a lot of people are using it and relying on it, they're vulnerable. And he might be a great programmer, but he might not have actually thought about writing secure code. And what you do as an organization when you use something like Handlebars, 87% of Handlebars releases are vulnerable, 37% of jQuery releases are vulnerable, 40% of Angular releases are vulnerable. As a matter of fact, if you're using Angular 1, you actually have no security fixes for the vulnerabilities in that. The team only put the fixes into Angular 2. They never backported them. They said that's end of life. We're not supporting Angular 1 anymore. If you're using these frameworks, then you're susceptible. And because of that single person that's writing that code, there's not a lot of people that might have security expertise. And you're basically getting 1,000 programmers to write software for you. You don't pay them. You don't check their work. And then they go. What's in that? You don't actually know. So what we've said here is we've said, let's help organizations manage that. The first place to do it is in the development environment. So this is actually an Eclipse plugin that we've got, and this is actually showing you the risk associated with all the libraries in that particular project. What I'm actually showing here is I'm actually showing you Spring MVC. This is from a company called Pivotal, who have released an open source version of the library. And as you can see, this is actually a timeline of Spring. And the version that you're using in your project is the one here, 3.2.3, and it has a critical issue. This red triangle, critical, this orange triangle is severe. There's actually 4 separate security alerts on that particular library. You can just click on that and see the list of CVEs. Here they are. You can go and research each of those. But I'm a programmer. I've used this library. What do I do? How do I fix it? So the idea is that we show you in the timeline that there is a version here in the future. These are all the different versions, all the different releases. 3.2.18 of this particular library, they've finally fixed the vulnerabilities. So what you can do is have a conversation with the developers and say, look, 3.2.18 of this one is fixed. Don't use 3.2.3, the one you currently got. Use the new version. because the vulnerabilities are gone. It's a very, very easy process to fix that in the design time, in the developers phase of the project. Because once you've released it and it's in production and you get a pen test done and the pen tester finds this problem, now you've got all that wasted time and money that you've spent testing and releasing software that was known to be vulnerable in the first place. So don't do that. What you do is you say to the developers, use this tool, we can show you that it's vulnerable, fix it on day one. That saves the bank, saves us a lot of money from actually releasing software that's known to be vulnerable to exploit. And this is a severity 9 exploit. This is a remote code execution again. And what you can actually do, click on that good version, with this button here called Migrate, actually updates the project for the developer. They can go and save that. I'm rebuilding my project. It's gone. It's no longer in my list of problems. And you get on to the next one. As a matter of fact, we had a bank in Sydney and they had 20 applications which they scanned and put into the server here. And when the DevOps lead took it to his lead programmer in one of the projects, she was shocked that she had all these vulnerabilities. She didn't even know. She actually sat down and did this, and she fixed it in 2 days. She wrote tests, unit tests to make sure that the software wasn't broken. She just went through and remediated all these issues. Done. It's actually quite quick and efficient to do it using a tool like this rather than having to do your own research. Because I've got 100 and something libraries in this project, and if each one of those takes me 4 to 8 hours to research, that's 800 hours of work. That's 20 weeks of one person. And that could be your best programmer, and she's no longer writing software, she's now looking for security problems. So you're no longer delivering new features, you're chasing security issues. And quite actually hard to do, because as you saw with that Spring project, there's hundreds of versions. So which one is actually a good one? How do you know? Similarly, this library here, this is called Commons Collections. It's actually another very famous library, 3.2.1. I've been traveling around the world, Germany, US, lots of different organizations that I've worked with to actually identify vulnerabilities. This library is in every single organization that I've ever worked with that did anything with Java. It's a very popular library. It's quite a base unit in Java. And it's 10 years old, this particular version. But what we find is that people are still using it because they don't know it's vulnerable. The exploit that was actually found was found in 2015. So for 7 years, people were using that library perfectly fine, no issues, they never had any vulnerabilities discovered. And then suddenly, in 2015, we find that it's vulnerable. And a lot of organizations actually are using this still to this day in 2018, and they actually don't know they're using that version that's vulnerable to attack. Again, a severity 9 CVE. But again, what we say is, well, this version here, 3.2.2, is fixed. And you can easily replace that library and you're done. So a little bit technical, I know. This is a developer's view of the world. Not all of us here are developers. Some of us are security people. And we don't go into the IDE. We just look at a report of the whole organization, the whole bank, whole insurance company. And that's what this view is here. This is listing all of the applications that we have that we've scanned in our organization with a listing of all the most recent exploits that have been found in it. We actually have a composition report here. We show you how many components are actually open source. This is the bill of materials. We show you everything that's in the project and whether they're vulnerable to attack. And then we have this special tab here of all the security issues. And one of the things that you might notice there is we have some CVEs, but we also have some Sonatype codes. Those Sonatype codes are for vulnerabilities that we found. So sometimes developers don't raise CVEs. What they might do is someone will tell them there's a vulnerability, they'll go and fix it, and then they'll just check it back into GitHub and move on. And they'll never raise a CVE. And interestingly enough, this happens all the time in JavaScript. So if you're doing anything in NPM, the vast majority of issues in NPM do not have a public CVE attached to them. So if you're only relying on CVE data, you're actually missing the vast majority of issues in JavaScript to this day. So what we've done at Sonatype, we've actually built an ingestion engine that ingests all of the GitHub events every day. There's 500,000 plus events where people are checking code into GitHub. We look at all of those, and any of those that are security related go to a curation team. We have 65 full-time data researchers that look at those approximately 700 events a day, and if any of those are security related, they will actually raise a Sonatype code against them. I'll give you a demonstration of that. This is actually a JavaScript library I'm going to show you now. So a framework, Happy.js, one of our customers is using that. There's a library in here. This is JavaScript that I'm showing you, called Growl. Growl is a popular JavaScript library. When I go and have a look at the vulnerability, it has the Sonatype code against it. And we show your team all the data that we've found, our explanation from our researchers, a recommendation or remediation for the programmers on how to fix this. And then down the bottom here, what I want to show you now is the advisory. These are the notes from the project team. Here's the GitHub. So what's happened here? Unsafe use of exec. Okay, I don't particularly actually even know what that is. I'd go and read up on it, but that team accepted that that was a problem in their project. They said, yep, problem. We've got a Jira ticket. I've fixed it. I do a commit back into GitHub, and I move on. The issue is known, it's public, there it is on the internet, there's no CVE. So if you're only relying on CVE data, you're missing the bulk of the data issues in JavaScript. That's why you need a tool to automate this that's actually ingesting all that data from GitHub to track it. Is that interesting? Has anyone come across this? Is anyone aware of this problem with GitHub and JavaScript? Are we using JavaScript here? Is anyone... Cool. So in the old days, people did raise issues and CVEs, but no longer is that done in JavaScript. And so what we did at Sonatype is we realized that, so we started ingesting all this data from the JavaScript world. This is an interesting quote. This is from a book called The Phoenix Project. Has anyone read that book? Good book, I recommend it to you. It's actually a sort of a fictionalized story about a company moving to a DevSecOps universe. It's written by Gene Kim. He's actually a pretty well-respected guy in this space. And he said, never pass a defect downstream. So what is he talking about there? I'm a developer by background, and when I first used to do programming, we'd write our code, and then testing was sent to a testing team. And we were no longer responsible for the QA or the quality of that component or that library or project. And they would send back all these bugs, and then we would fight with them, and then we would fix it, and then we'd go again, and there'd be this constant loop, and it's very inefficient. And then when we'd finish that and we'd pass the testing, we would send it to the security team, and they'd do a security assessment, and they'd find all these security issues, send it back to us, we would rewrite it, retest it, and go again. A year, I was an insurance company doing this, and it took us a year to 18 months per release because it was just so inefficient. We're just wasting cycles writing software that was buggy and laden with security issues, but we sort of didn't care because it was somebody else's problem. So what DevSecOps is about, I talk about changing culture and changing the way we do things. Teams that used to be responsible only for coding are now responsible for coding and testing. Teams that are responsible for coding and testing are also now responsible for security. So it's DevSecOps. And also for the deployment. You write it, you deploy it, and you test it for security issues. So you, as a programmer, are now going to be made responsible for your security issues, along with your quality issues. So security becomes a testing phase. And this book sort of dramatizes that. It's a really big culture change. And the reason why this was done was because Toyota did this many years ago. They said that you cannot inject quality into a car at the inspection phase. It's too late. give the developer or the builder of the car the ability to check for quality issues and fix them on the spot. And in the car business, they talk about pulling the andon cord. So the andon cord is this cord that you can pull when you're making your car that stops the production line. And what that pulling of the cord is about is I've got a quality problem that I can't solve myself. But what it really means is bring in a team leader, bring in someone more experienced to help me, to actually help me to fix this quality problem. Similarly, in the software business, we want the developers to be able to bring in a lead developer to show me how to fix this problem. This is one of the culture changes that's quite difficult to make. And one of the banks I work with in Sydney, they actually said that what we said was to make our quality better, whenever a programmer commits something into our repository, he's actually declaring this is fit for production. That's what that statement means. We're empowering you to release this to production. That's the culture change. Traditional software manufacturing inside of banks was the developer wrote the software and then somebody else tested it for quality. Somebody else approved the release. And that person could be 3 levels above me in the organization, have no idea what I've done, but it's his job to approve a release. Quality was really bad. Releases were very slow. Now that we give the developer the responsibility for the quality, quality goes up because I own the quality and the security. So I'll show you how we do that in our tool. What we can do is we can actually automate the process of you bringing in components into your organization, even blocking them from being brought into the repository in the first place. What I'll do is I'll show you how we do that. I'm going to do a Jenkins here. This is a popular tool for building software. And what I'm going to do is I'm actually going to block a component coming in. Give me a second. We're going to simulate a programmer, bring in a library, and this library is going to make our software environment worse if he brings it in. So I'm going to add a policy that says no longer can I bring in bad libraries that have known security problems. I'm going to check for a vulnerability. We have lots of different ways of checking for software quality as we bring in libraries. What I've said here is I've said no software vulnerability greater than or equal to 7. I'm going to block it at the proxy, block it at the firewall. Okay, great. So let's just recap. I've got a policy here. This is our policy engine that we run. This is our bank. We've said, okay, from now on, no more bad libraries. Now let's simulate someone trying to download one into our business. This job does that. So that takes a couple of seconds. What I'm actually doing is I'm downloading some software from GitHub. This actually got a vulnerable component in it, but the firewall that we have blocked it. Great. It's been failed. Let's have a look at that. Okay. There's an icon there that tells you with a little circle and the cross through it, that's been quarantined, that's been blocked. Oh, I didn't know that. Why can't I download that library? Okay. It's actually Commons Collections. This is the quarantine icon. When I click on that, I can see my policy here has been breached, greater than or equal to 7. Oh, okay, what is that? Oh, okay. There's actually a level 9 CVE has been registered against that component. So just to recap, what we're saying here is developer is building a car and he goes to get a bit for his car, but it's actually a bad bit. We don't want that bit in our car. So we stop that. And this is the same thing with software. When you write software, you actually assemble software from components, but we don't want the programmers building it with bad components, known bad components. We block it at the firewall. We block it before it actually comes in. And what we say is, this version here has been blocked, known to be vulnerable, use a better version. So you can actually have that conversation with the developer to go back and tell him in future, use a better version of the library, don't use the vulnerable version. And that's what we call the firewall. All right, so I'm mindful of time. I'm near the end of our slot. Is this interesting for anybody? Cool. Any questions? Wait for the microphone. Just wait for the microphone, sorry.
I see you're automating blocking the bad version. Can you not automate downloading the good version?
Yes, you can do that. So you can actually tell it to actually download the good version. There's different ways of doing that. One of the things that we show you here, if you notice the color, how it goes from green to blue in the top, that green color is actually telling the developer it's actually the same release, the same major release that you're using. The blue one is actually a different version, so it's not backwardly compatible. So this is actually telling the developer that the green one is a non-breaking change to your software, the blue one is a breaking change. And you can then use that as a way of actually bringing in the right version of the library through the repository.
I think this can be done through an interactive process. What I'm saying is scan the entire repository that I have today, and from time to time you may find new vulnerabilities in my existing repository. So scan my existing repository. If I find anything vulnerable, replace it with the next best version.
Okay,
so I can rebuild my objects.
Yeah, so the question is, we scan the repository and we find that it's vulnerable. Let's rebuild it with the next best version that's not vulnerable automatically. The answer is you can actually script that if you want, but traditionally a lot of organizations don't do that because we actually want the developer to be aware of it and actually remediate it, because you could potentially introduce a problem that you're not aware of, some quality problem. So what we're saying is the developer can script that and he can do that, but you want them to go through the process of actually being made aware of it and them changing it and actually being in control of that change and fixing it. You don't just want to automatically ingest that from some other person and change people's projects on them. You can do it, and I know people have scripted it, but traditionally we want the developer to own the problem and be made aware of it, because you want them to do some unit tests around that change. So if they do change a library, you want them to actually write a unit test that confirms that that change has actually worked and hasn't broken the system. So that's usually the most common approach. Sorry. Any other questions?
I just want to confirm, you had said that the Equifax breach was preventable and it was based on a struts vulnerability. Is that correct? What was the vulnerability that actually caused that?
Okay, so struts, the question is struts, the Equifax breach was based on a struts 2 vulnerability. So yes, it was. The way we know that is because Equifax told us that, and it was confirmed by other researchers, and we know that Equifax uses struts. I demonstrated that with my Google attack. And Equifax actually had, let me just have a quick look here. I've got some references for that to confirm it. I'm happy to share this. Where are we? So this is the CVE here. And you can actually read up on it. And the exploit was, let's just have a look at Equifax here. Yeah. So there's a number of articles here. At the time, Equifax actually wrote a document in their crisis management to actually explain how it occurred. Actually raises a good point. A lot of organizations that are attacked don't always tell you how it was done. So I've actually got a list here of the companies that were attacked recently using open source libraries. So the Panama Papers, I mentioned that. Equifax is another one. Heartbleed was another one, OpenSSL library, Canada Revenue Agency. Lots of organizations talk about it, whereas someone like Shell Shock, for example, not a lot of organizations explained how they were attacked. The reason being is they were still vulnerable. It was quite hard for them to patch. But we have pretty good evidence that Equifax was a struts vulnerability. Any other questions? Okay, thank you.
Okay. Thanks, Cam. So we will break for lunch.